Hello, and welcome to this short video explaining how we would find the maximum area of a rectangle which just touches a curve. In this case it's a cubic curve there, which is y equals 8 minus x cubed. These kind of questions are great because they test the use of the concepts of calculus. So you see the question doesn't actually mention calculus, but nevertheless that's what we need to use to solve this. How would we find the area of such a rectangle? Well, we would first form an equation for the area of the rectangle in terms of x, then we would differentiate that with respect to x, and then we would set that equal to 0. And now, since the derivative tells us the rate of change of the area, setting that equal to 0 will find the turning point of the rate of change, and that will tell us the x value of the rectangle that has the largest area. And intuitively, if we could picture this, we can imagine that for a very small value of x, the rectangle will be a very, very thin slice, and then as we move across, the rectangle will get larger and larger, and then we'll pass the maximum point, and it will begin to once again become a thin slice, this time parallel with the x-axis. So as a first step, let's just examine this curve. So where does this curve cross the x and y axes? Well, we can find that by setting x and then y equal to 0. Okay, and if we do that, we can see that if y equals 0, x equals 2. And we can find the y-intercept very straightforwardly just by setting x to equal to 0, and we can see right away that y equals 8. So that can help us picture the situation. And now we have to ask ourselves the question, what would the area of the rectangle be? Well, the area of a rectangle is always the length times the breadth. So in this case, that's just going to be x times y. So a equals x times y, but in this case y is a function of x, so we should substitute that, the expression for x, in here instead of y. And the reason we're doing this is, again, because we're going to differentiate this with respect to x, and so therefore we need it to be in terms of x. Had we differentiated by treating y as a constant, we would have gone wrong, because y in fact isn't constant with respect to x. Okay, and there I've just expanded that bracket to neaten up our expression. So now we need to differentiate that with respect to x. Okay, and we find that dA dx equals 8 minus 4x cubed. So now we must set the derivative equal to 0 and solve for x. Okay, in doing that we find that x is equal to the cube root of 2, and the cube root of 2 is 1.2599. So intuitively that seems like a believable value, because the curve crosses the x-axis at 2, and we're saying the maximum is about 1.2. So yeah, it seems believable. So then we need to work out the actual area of this. So that's just the x value, but all we need to do now is substitute that x value in to our equation for a above. So we'll do that now. Okay, now having substituted that in, we can see the area is 8 cube root 2 minus 2 root 2.